We often view tree planting as a universal good for the climate. However, certain species behave differently when introduced into a foreign environment. When a tree rapidly outcompetes the native flora, it shifts from an asset to an invasive force that can dismantle the local landscape. Take the eucalyptus. Originally native to Australia, it was exported worldwide and selectively bred by the global timber industry for a single trait: explosive vertical growth. From a distance, these massive plantations look like lush, thriving forests. But look to the left side of this landscape. The data reveals a different reality. These tightly packed rows are entirely devoid of native wildlife. Ecologists call them green deserts. In Brazil, industrial pulp facilities are scaling up land-based geoengineering. Corporations are planting vast tracts of genetically engineered clones, like the H421 strain, specifically to increase the velocity of wood production. Because these clones grow so rapidly, companies frame the plantations as carbon sinks, selling carbon credits to global policymakers as a primary climate mitigation strategy. The ecological cost is quantifiable. In regions like Brazil's Alto Jequitinhonha plateaus, these eucalyptus monocultures have already replaced 61.5% of the native, highly biodiverse Cerradova vegetation. Corporate ledgers may claim carbon neutrality, but those spreadsheets omit the biological reality: the systematic displacement of native biodiversity. To understand how a single species can destabilize an entire ecosystem, we have to look beneath the soil at its predatory root system. This map shows the Kwame study site in South Africa. Researchers here tracked genetically improved eucalyptus hybrids and found that a 9-year-old tree transpires between 2.3 and 3.3 millimeters of water every single day. The mechanics are highly efficient. Tap roots bypass the dry surface, reaching the unsaturated zone to extract water 28 meters down. This creates a groundwater deficit. A native biome absorbs 50% of rainwater for recharge, but eucalyptus absorbs only 29%. This hoarding forces local human populations to deal with the shortfall. Family farmers bordering these plantations survive on an average of just 43 liters of water a day, less than half of the World Health Organization's recommended minimum. The eucalyptus functions as a massive biological pump, concentrating the regional water cycle within its own biomass and depriving the surrounding community. The devastation continues on the surface. Walk through a eucalyptus plantation and look at the ground beneath the canopy. You will notice it is sterile. This is the result of allelopathy. As eucalyptus leaves decay, they leach toxic compounds, terpenes, phenolics, and alkaloids, directly into the dirt. These toxins target competing flora, dropping chlorophyll levels by up to 54% and blocking cellular mitosis. Over time, this chemical shedding creates hydrophobic soil. The ground literally repels water, preventing native underbrush from taking root and removing wildlife habitats. By chemically altering the soil to inhibit cell division and repel moisture, the tree ensures an absolute biological monopoly over its environment. The tree's evolutionary advantage is finalized in its canopy and bark, which are built to utilize fire. The leaves are packed with flammable volatile oils, and the trunk sheds long, dry strips of bark. These strips act as fire ladders, catching small ground blazes and racing straight up to ignite intense crown fires. Once the fire burns out, the eucalyptus relies on epicormic sprouting. Beneath its thick, insulated bark, protected buds survive the heat and sprout within weeks, allowing the tree to claim the freshly cleared, nutrient-rich ash. The physical architecture of the eucalyptus facilitates these catastrophic blazes. By providing fuel to carry fire into the canopy and protection to survive it, the tree incinerates competitors to claim the resulting ash. Across Brazil, human resistance is challenging this model. Grassroots organizations like the Landless Workers Movement and traditional Quilombola communities are marching to reclaim their traditional lands from corporate monoculture giants. Ecological data confirms that this resistance yields results. In South Africa, a government initiative called the Working for Water program conducts physical audits and removes invasive plants. The results of these removals are immediate. By clearing eucalyptus from riparian zones, dormant springs reactivate and natural stream flows return to the watershed. As global climate strategies evolve, the focus is shifting away from corporate monocropping and toward policies that prioritize biological complexity. Securing water sovereignty and stabilizing our ecosystems requires dismantling botanical imperialism in favor of true biodiversity. To further explore the science shaping our planet, hit the subscribe button, activate the bell, and stay tuned for the next TEMBODocs investigation.